Hi children, I am Ansi. Welcome to Ansi's Learning Hub. Today we are doing the continuation of trigonometric ratios. Okay, so today we are learning a special concept in trigonometric ratio. Okay, already we defined all the 6 type of trigonometric ratios of an acute angle in a right angled triangle. Today we are discussing another point, which is that means the values of a trigonometric ratios of an acute angle, whatever the acute angle, only two acute angle in a right angle triangle, right. So values of an acute angle, trigonometric ratios of an acute angle do not vary with the length of the sides of the triangle. If you increase the length of the sides of the triangle, accordingly the values of the trigonometric ratio will not vary. That is what. How can you prove it? We can do it. Like suppose let us have a triangle ABC, right angled at angle B. So this is right angled at B. So this is my right angle triangle ABC, and if I am taking a point P on the hypotenuse of this right angle triangle ABC, and again I am taking one more point on this hypotenuse by extending this AC to till Q, and from there also I am both P, from P and Q I am dropping a perpendicular. First perpendicular PM. PM is a perpendicular I am dropping to the side AB, and QN. QN is a perpendicular I am dropping to the side AB extended to BN. Okay, this Q point also I took from by extending the side AC. So this PM, that is again 90 degree, QN also 90 degree, right. So now suppose if I am taking the triangle PAM, PAM, this is the small triangle PAM, and QAN, triangle QAN, this big triangle. Okay, in this both triangle, if I find the trigonometric ratios of this angle, acute angle A, so in this small triangle APM, or we can say PAM, or big triangle QAN, is this trigonometric ratios of this acute angle A will be same? That is what we can check. So let us consider first the triangle ABC, triangle ABC, or I can say CAB, both are same, right angled at B. Okay, so consider the triangle PAM and triangle CAB. In this both triangle, when you consider, you can see that angle A is common. Angle A, you can see angle A is there for both the triangles CAM and CAB. We have angle A as well as this angle M in PAM. This much small triangle PAM, there is angle M, that is 90 degree, and in CAB, this angle B is again 90 degree. So in the triangle PAM and triangle CAB, we can see two equal angles, right. In both triangles, we are studying in similarity of triangle. If two angles in a triangle is equal to two angles in other triangle, then these two triangles are similar. Because here actually this angle is common for both the triangle as well as 90 degree. So automatically that third angle also will be equal. But at least two angles are equal means that two triangles are similar. Okay. So I can write triangle PAM, triangle PAM, triangle PAM similar to triangle CAB, triangle CAB, okay, triangle PAM similar to triangle CAB. If both triangles are similar, I can say the corresponding sides are in same ratio or they are in proportion. Same ratio means they are in proportion. We can say all the value will be same. That ratio will be same. Let me take it as a constant K. So let me take triangle PAM. PAM, there is a side AM. So AM is the side in triangle PAM. correspondingly which is the side in triangle CAB. Okay, triangle PAM we have AM and triangle CAB we have AB. So AM by AB, that is a ratio. Okay, AM is coming in PAM and AB is coming in what? CAB. Okay, so that has AB. So this much side. So AM by AB equal to what? AP. AP is what? That is the hypotenuse of this small triangle. AP by AC. AC is the hypotenuse of the big triangle. Okay, AM by AB is equal to AP by AC equal to PM by CB or BC. PM, that is MP by BC. That means MP by BC. So all the three sides of one of the triangle is in proportion with the other corresponding sides, right? Corresponding sides of two triangles are in proportion. Okay, so AM by AB, that is by similarity of the triangle, we can prove like that. Okay, now when you consider triangle APM, this reference angle, let me take it as angle A. So what is sin A in triangle APM? Sin A is equal to what? We already studied the trigonometric ratios, opposite side by hypotenuse. So in triangle PAM, opposite side, which is opposite side for this reference angle A, that is PM. So PM by hypotenuse. What is hypotenuse? PA. So PM by PA. This is sine of angle A in triangle PAM. In triangle PAM. In triangle PAM, sine of angle A is PM by PA. Now let me take triangle CAB. In triangle CAB, what is sin A? Again the same reference angle. So sin A is equal to what? Sin A is equal to opposite side. Which is opposite side in triangle CAB? That is BC. Opposite to this angle A, which is the opposite side, BC in triangle CAB. CAB. CB is the opposite side and AC is the hypotenuse. So in the case of triangle CAB, I will write opposite side as CB and hypotenuse as AC. Okay, this is in the case of triangle CAB. So this sin A and this sin A we can check. See, this is PM by PA and here it is CB by AC. When you check here, you can see PM means MP. So if I equate AP by AC, this is AP by AC, already we proved they are similar, right? So AP by AC equal to MP by BC, right? So if I transpose this BC to this side, what will happen? This is in the denominator. It will come to this position and AP will occupy this position, right? If I am transposing this AP to the right hand side. So I can write BC by AC equal to what? This AP will come into the denominator. MP by AP. This is what, right? This is what. So I can write BC by AC equal to MP by AP from this similarity itself. We know what is sin A, that is PM by PA, that is what MP by AP, both are same, right? I can write MP itself. PM means MP, and AP means PA. I can write AP itself, right? So let me write it as AP. So sin A is equal to MP by AP and sin A for the big triangle, what is it? CB I can write BC by AC. CB and BC are same, right? So I understood that sin A is same for both the triangle. Same thing will happen if you are considering triangle AQN also. So if you are having different big triangle, but the same reference angle if you are taking, the values of the trigonometric ratios of that particular angle do not vary with the length. Here length increases but the ratio will be same. So we understood that sine of angle A for the smaller triangle and sine of angle A for the bigger triangle also both are same, right. Sine A, here it is MP by AP, here it is BC by AC, that is what. So this is the big breaking part in trigonometry. That means for a particular reference angle, we have two acute angle, we are considering a right angle triangle, the ratio we are making sine, cosine, tangent all will be same, that will be constant for a particular angle. Suppose our reference angle A is 30 degree, that sine of angle 30 will remain constant whether this is a big triangle or a small triangle, but the angle here if it is 30 degree, sine of angle 30 degree always will remain constant. This is very good, right. So if you know that value, how much is the constant for sine of angle 30, if you know, easy, right, we can find out other sides of this triangle. That is very much good for finding out all the sides of a triangle in a right angled triangle. Okay. So suppose if I have sine of angle 30, we can, if little bit tough for us to find out that angle. Suppose if here see this side is 20, hypotenuse is 20 and the opposite side is 10 degree. Then sine of angle 30 will be what? Sine of angle 30 means opposite side by hypotenuse. So opposite side of this big triangle is 10 and correspondingly hypotenuse is 20. So sine of angle 30 will become 1 by 2. So that value half, that is always constant. That is interesting, right. So here if I take sine, again here if I am taking 30 degree itself, instead of this 10 unit, here it becomes, suppose I am making 5 unit, here this hypotenuse accordingly let it be 10, because 10 by 20 I divided both side with 2, so it comes 5 and 10, right. So here what is cos sine 30 in this small triangle, again sine 30 become 5 by 5 is the opposite side BC, right, 5 by 10, that is half. That means if this reference angle here it is 30 degree, opposite side by hypotenuse always will be half. So if you know the value of the sine 30, it is easy for us to calculate the other sides, right. So in order to find out different angles, some of the angles like some type of angle, suppose if I want to find out cos 30, what is cos 30? Here it is 10, here it is 20, then this side AB, of course by Pythagoras theorem, hypotenuse square minus height square will give you here 10 root 3. Okay. Cos 30 we can get adjacent side by hypotenuse. So cos 30 becomes how much? 10 root 3 by 20. 10 root 3 by 20. So it will be root 3 by 2. In the small triangle, cos 30 will be how much? Cos 30 will be adjacent side is here 5 root 3. So 5 root 3 by 10. So here it will be root 3 by 2 itself. We can understand that here it is root 3 by 2 and here it is again root 3 by 2. So here cosine of that angle 30, that will remain constant even if you have a big triangle or a small triangle. So it is interesting if you know the value of angle, at least some angle, suppose let us say 0 degree, 30 degree, 45 degree, 60 degree, 90 degree, this much angle, if you know the value, the ratios, then the ratio value here 30 degree value, here we got half. I told you sine of angle 30 always will remain half itself. So if I know two sides ratio is half, that means opposite side by hypotenuse ratio is half. I can easily say this angle here it is 30 degree, right? So that is what we are doing here. So in order to find out that angle, we can use a method. See, suppose if your left hand left hand, if you are placing like this, thumb will come in the bottom side, then forefinger, middle finger, ring finger and little finger. Like that it will come, right? So, bottom side your thumb. So, sine of this angle, any angle if you want to find out which angle, suppose 0 degree angle I need. So, I will keep sine 0 equal to under root the fingers below. If I take 0 degree, any fingers below you can see? You cannot. So, the formula for sine of that angle is under root fingers below divided by 2. Under root fingers below and divided by 2. So, sine of angle 0. So, and also you name the angle thumb 0 degree. Next finger, forefinger 30 degree. Middle finger 45 degree. Ring finger 60 degree and little finger 90 degree. Maximum value you can give for little finger. Minimum value for thumb. Like that, if you are arranging like this. Now, let me say if I go for sine of angle 0. So, what is the formula I have written here? Sine of angle 0. Sine of angle 0 degree. That is equal to how much? How much is the value? So, I can keep my finger like this. So, fingers below of this 0 degree, any finger? No. So, I can write here under root fingers below is 0 divided by 2. So, sine 0 is 0. So, without taking any paper, even in the exam hall you can use your fingers, left hand you are using like this. Now, you are going for sine 30 degree. 30 degree if I am forefinger, right, 30 degree for forefinger. So, below this forefinger how many fingers are there? One finger, right. So, sine 30 degree, how can I write? Sine 30 degree. So, under root fingers below how much? If I am taking 30 degree, one finger below divided by 2 is there, right. We are writing like this. So, sine 30 degree is how much? Root 1 is 1 itself. I got half. So, sine 30 degree we got, see, a root of fingers below is 1 divided by 2. Root 1 is 1 itself, 1 by 2. So, sine 30 degree I got 1 by 2. Now, let me go for sine 45. So, my middle finger is corresponding to this 45 degree, third angle, right, sine 45 degree. So, below 45 degree I have two fingers, right, fingers below I have to check, fingers below two fingers are there. So, let me go for sine 45. Sine 45 degree is equal to how much? Under root fingers below, there are two fingers below 45 degree. Below 45 degree there are 2 fingers. So, go for that is what this 2, right, under root fingers below by 2, that is in the formula. Fingers below you have to keep under the root. So, the formula comes root 2 by 2. Root 2 by 2, this 2 I can write, instead of this 2 I can write what? Root 2 into root 2, right. So, 1 root 2 will be cancelled and I can write 1 by root 2. This is the value for sine 45. Then let me go for sine 60 degree. Sine 60 degree, if I am going under root fingers below. So, under root fingers below. So, take 60 degree, below how many fingers? 60 degree below you can see 3 fingers, right. You are using your left hand. So, 60 degree for your ring finger below you can see 3 fingers. So, that 3 you have to write here and divided by 2. So, what is sine 60? Root 3 by 2. Again for sine 90. Sine 90. So, you are again using your left hand, 90 degrees for your forefinger, little finger. So, what are the below, how many fingers are there? 1, 2, 3, 4 fingers are there. So, under root fingers below, that is 4 divided by 2. So, under root 4 is how much? 2. 2 divided by 2 comes 1. So, we got this much ratios of different angles, 0, 30 degree, 45 degree, 60 degree, 90 degree. So, sine of the angle we got easily. So, you can use your left hand side, left hand fingers and make this ratio easily. Formula is what? Under root fingers below divided by 2. That's all. Now let me go for cosine of the angle. So if you know this ratio, that is what we studied. This ratio always remain constant. Even if you have a small triangle, big triangle, doesn't matter. Length of the side increases, doesn't matter. Only the thing is angle should be 30 degree. Okay. Even if in small triangle, big right angle triangle, we can get this 30 degree angle, right. So that is what all about sine of the angle. Now let me check the cosine of the angle. When you go for cosine of the angle, cos theta, right, cosine of a particular angle, cosine of the angle, if you are writing, instead of fingers below, you have to go for fingers above. That is what cosine of the angle. In order to find out, under the root you have to place what, under the root you have to place fingers above, fingers above. How many fingers above my particular angle, which is my reference angle? Above that reference angle, suppose let me take 0 degree. How many fingers are above this 0 degree? 4 fingers are there, right? That is what fingers above, that you have to keep under the root, then put 2 divided by 2. So let us go for cosine of angle 0 degree. How much? So 0 degree is this one, thumb, right? So how many fingers are above thumb? 4. 1, 2, 3, 4. So I have to put that 4 fingers above divided by 2. So root of 4, how much? 2. 2 divided by 2 comes 1. So what is cosine of 0 degree? That is 1. Easily we got. Then we can go for cosine of angle 30 degree. So this is our reference angle, 30 degree, right? So this is fingers above, I have to check. Fingers above, how many fingers are above this 30 degree? 1, this is our forefinger, right? 1, 2, 3. 1, 2, 3 fingers are above. So make it 3 divided by 2. This is what cos 30. Cosine of angle 30 is how much? Root 3 by 2. Now cosine of angle 45 degree, how much it will come? See, again you take your reference angle 45 degree, fingers above I have to check, right? To check cosine of the angle, fingers above 45 degree. There are 2 fingers, so under root you keep root 2, 2 fingers above, divided by 2 is there again in the formula. Root 2 by 2, instead of this 2 I can write root 2 into root 2. So this root 2 cancel. So again cos 45 I got 1 by root 2. Okay. This is cosine of 45 degree angle. Now let me go for 60 degree angle. When I go for 60 degree angle, cosine of angle 60. Cosine of angle 60 degree is equal to under root fingers above. See, 60 degree if I am taking, finger above is only 1 finger, my little finger, right? So that is 1 finger above divided by 2. So that is equal to what? Root 1 becomes 1, 1 by 2. So easy, cos 60 we got half. Now one more angle, that is cos 90. Cos 90, how much it will come? Cos 90. Cos 90, when you take fingers above, no fingers above, right? Cos 90. Cos 90, fingers above, you have to put under root. Fingers above, if I take cos 90, no fingers above, so keep it 0. 0 fingers above, 90 degree. Again below you can put 2 itself. So answer is 0 by 2, that is 0. So cos 90 value we got 0. So now we got all the values corresponding to 0 degree, 30 degree, 45 degree, 60 degree and 90 degree for both sine as well as cosine. Okay. Now if you go for tan, here sine and cos, when you check these angles again, you can see that sine value is increasing from 0 to sine 0 value we got as 0 and sine 90 value you got 1. When just now we did, right, like that. So this value is increasing from 0 to 1. When you check cos of the angle, cosine 0, that is 1, right, fingers above, that we find out, right, cos 0 is 1, but cos 90 value we got 0. So, sin 0, sin value, angle if it increases, it is going from 0 degree to 90 degree, the value is increasing from 0 to 1. But in the case of cosine of the angle, value is decreasing from 1 to 0. Okay? When you go for 0 degree to 90 degree, this is the variation happening in sine and cosine. And we know that what is tan theta? We already studied trigonometric ratio. We know that tangent of an angle is sin theta by cos theta, right? That is what. So, I can go for this formula, tan theta. So, tan of the angle, if you want to find out tangent of tan theta, I can take it as 0 degree. So, for that, what is the formula I have to use? Under root finger, this 2 and 2 will cancel if I write sin theta by cos theta, right? So, fingers below divided by fingers above, under root fingers below divided by under root fingers above. So, you can use your left hand itself 0 degree. If I am going for 0 degree, under root fingers below, any fingers below, can you see when I use this tan 0 reference? No below, right? So, it will be 0, and under root fingers above, there are 1, 2, 3, 4. When I take this reference angle 0, so divided by 4, that will be 0 itself. 0 divided by any number is 0. Okay. Now, we can go for tan 30 degree. This is our reference angle, 30 degree. So, tan 30 degree, how can I? Under root fingers below this 30 degree, one angle. So, 1 I am keeping under root, and divided by fingers above this 30 degree, how many fingers? 1, 2, 3. So, under root 3. So, this answer will be 1 by root 3. This is what tan 30. Okay. Now, when I go for tan 45 degree, fingers below 45 degree, how much? 1, 2. So, under root 2 divided by fingers above. When I take this 45, above is again 2. So, you are taking your left hand and doing this one. So, this 45 degree above you can see 2 fingers. So, root 2 by root 2 becomes how much? 1. So, what is tan 45 degree? 1. Tan 0, 0, tan 30, 1 by root 3, tan 45, 1. Now, we can go for 60 degree, tan 60. What is tan 60? Tan 60, so tan 60 when you write, fingers below how much? Under root fingers below. When I go for this 60 degree, below you can see 3 fingers, and above how many fingers? Above 60 degree only 1 finger. So, answer is under root 3. So, all in the paper also you can keep your fingers like this of your left hand. So, 60 degree if you are taking 1 finger above, 3 fingers below, right. So, below fingers you are writing in the numerator, above fingers you are writing in the denominator. So, root 3. Then you can go for tan 90. Tan 90, how can I write? Fingers below. If I go for 90 degree, below fingers are 4, right, 1, 2, 3, 4. So, root 4. And what are the fingers above this 90 degree? No fingers, right. So, that will be fingers above will be 0. So, anything, if you cannot divide anything with 0. Root 0 means 0 itself. So, not defined. Tan 90 not defined. We can write what? Tan 90 is not defined. So, we find out the trigonometric ratios for a specific angle very easily from 0 to 90 degree. Okay. Now, we can do some problems based on these ratios, right. So, if you know the angle very well, easily we can do some problems also. Here, see tan 90, if you know sine, cosine and tangent of this particular angle, what about cosec, sec and cotangent, they will be just reciprocal. Suppose like that, sin 30 we know, now we understood that is sin 30. If you want, you just keep your left hand like this and fingers below this 30 degree 1. So 1 I will keep here 1 by 2. So sin 30 is how much? Half. Okay. Then what about cosec 30? Cosec 30, cosecant of angle 30, that will be equal to just reciprocal. Here it is half, so that becomes 2 by 1. So if you know sin 30, easily I can go for cosec 30. Same way, if you know cos 30, how much is cos 30? Simply keep your left hand like the 30 degree, that is your reference angle. So fingers above this 30 degree you have to check. 3 fingers above, right? So fingers above. So cos 30 is equal to how much? I have to go for fingers above this 30 degree. Under root 3 divided by 2 is there in this formula itself, right? Fingers above by 2. So we got cos 30 is root 3 by 2. So what about the reciprocal of cos 30? Sec 30. Sec 30 is how much? 2 divided by root 3. This is what? Like that, if you know first 3, sine, cosine and tangent, then we can go for cosec, sec and cotangent easily. Okay. So we got it. Now let us do one problem based on this ratios. Okay. So let us do one question. See, suppose if sin A minus B, sin of A minus B, if sin A minus B, if sin A minus B is equal to half, that is what they have given. Sin A minus B is equal to half cos A plus B, cos A plus B. So whatever you are writing on the right hand side of this trigonometric ratio, this is an angle. Okay. Cos A plus B is equal to again half. Okay. So you should understand that this ratio is this much. So what should be this angle? So just now we have seen that sin 30, sin 30 when you take, you got 1 by 2 because you know fingers below is 1 by 2, right? That is the formula. Sin 30 value, that is what we got half. So what is this A minus B? Sine of an angle. That value, if it wants to become half, this A minus B value of course should be how much? 30 degree. That is a constant for sine of angle, right? So A minus B we got 30 degree. So now if I go for cosine of A plus B, so of course you should understand this A plus B is an angle. Okay, this angle, that ratio, cosine of that particular angle should be half. From this calculation we understood that that angle when it comes as 60 degree, then only this cos 60 is half. So of course A plus B should be how much? 60 degree. That is what? Cos 60, cosine of angle 60 is how much? Half, right? Cosine. Now if I consider cosine of A plus B, so you should understand after cosine something is written, that should be an angle. That angle is giving half, that is a ratio. So A plus B should be how much? That should be 60 degree. That means cosine of 60 degree will give you half. That's the meaning. Same way sine of angle 30 degree will give you half. That's the meaning. Okay. So we understood that this A minus B constitute 30 degree and A plus B constitute 60 degree. So we got actually two equation, equation 1 and equation 2, right? So from equation 1 and 2 we can find out, here I don't know the value of A as well as B. In an equation if you don't know two variable, A is a variable, B is a variable, both value I don't know. So from a single equation I cannot find out. So we have two equations here, equation 1 and equation 2. So let us add equation 1 plus 2 by, then this positive b and negative b will be eliminated. A plus a becomes 2a. 2a is equal to how much? 60 plus 30, 90. So a is how much? 90 by 2, that is equal to 45 degree. Okay. So a value I got 45 degree. Now I know in this a plus b, suppose any equation you can substitute this value of a in substitute in equation 2 because it is a plus equation. So for a plus b 60, a I got 45, 45 plus b is equal to 60. So b is equal to how much? 60 minus 45, that is equal to 15 degree. So now I got a is 45 degree, b is 15 degree. That's all. Like that we can do whatever the problem we need, we can do if you know the ratio corresponds to which angle. Okay, that's all.